So this lesson is not actually a section in our Algebra 2 book. It's kind of a precursor lesson to what we're going to do next, which is completing the square. But first we have to go back and discuss how you solve a quadratic that is already to square root. And I feel like this is something that we haven't seen a ton of in geometry and very little in Algebra 2 or Algebra 1. So just because of the time that's in between when you first learned it, when you're expected to remember it again, I think we need to revisit it. So at the top of your paper, you're going to see a line of the first few perfect squares. So like 1 squared is 1, 2 squared, 3 squared, 4 squared, 5 squared, and so on and so on. And the idea, if the number r is a square root of the number r squared equals s, you have both positive and negative answers. Okay, there's a very deep conversation about why that is, but for you guys, we just have to think about if you have a quadratic graphed square root quadratic, and you want to know where it hits a certain value, it's going to have both positive and negative roots where it intersects. So that's the easiest description I can come up with for someone at the Algebra 2 level. This symbol, remember, is the square root sign. It's the radical. And because we're going to be dealing with square roots for the quadratic unit, these are all going to be square roots. So big note to yourself, when you apply square root in an equation, and this is the big difference, okay? It has to be an equation. The plus and minus sign shows up. And it's very clear that that's when it shows up. The minute that you apply a square root sign to both sides of the equation, that is where both positive and negative solutions occur. We're going to see problems where that happens at the beginning of the problem, and then we're going to see problems where that happens towards the end. Now, before we actually solve using square roots, let's remember how to simplify square roots. So we're going to break up this radical into a product of two numbers that multiply to 24, but you have to look inside this list. So like 24 would have been inside this list, so if you kind of cut off this list and look below it, which one of these guys is the biggest one that divides into 24, and that would be 4. 4 times 6 is the same thing as 24, and then I have a way better name for the square root of 4, that's a 2. Let's reduce it to 2 squared to 6. Similarly, for 12, 12 would have shown up right here in this list, so looking down below where 12 would have shown up, 4, again, is the perfect square that's a factor of 12. So 4 times 3, I again have a better name for square root of 4. This is 2 times the square root of 3. Careful on 48. 48 shows up kind of further down the list, right? It would have been right there. So working backwards in this list, you got to figure out which is the first number, or the biggest number in this list. That's a factor of 48. A lot of kids tell me 4. The problem with that is 48 is 4 times 12. There's still a lurking perfect square inside there. Actually, it turns out 16 is the first, the largest perfect square. 16 times 3. So better name for 16. Square root of 16 is 4. This is 4 times the square root of 3. Now don't keep square rooting, guys. That's just 4. It's not the square root of 4. Sometimes kids think anytime they see the number 4 from there on out, they should just keep square rooting. And then for 28, if I look inside my list of perfect squares, 28 would have been right here. Looking down the list, back to our friend the 4. 4 times 7, which is 2 squared of 7. So that's a little refresher. We did a lot of that back in the last unit. I'm going to skip ahead. Remember when we divide perfect square roots, this can be separated into square root of 4 over square root of 9. Square root of 4 is really a 2. Square root of 9 is really a 3. Similarly here, we have square root of 2 over square root of 3. Now, unfortunately for us, square root of 2 doesn't simplify, and really unfortunate is square root of 3 doesn't simplify. And then there's some weird rule out there that states, equal sign here, that states you can't have it radical in the denominator. So the way we, quote, got rid of it is we rationalize the denominator, the word, and you think about what undoes a square root, and the act of squaring undoes a square root. Well, you can't just willy-nilly square things in a fraction and think you're going to keep it balanced. But what if I multiplied by the square root of 3? Because that is the same thing as technically squaring a square root of 3. So here's the trick. As long as you multiply the numerator and the denominator by it, you're okay, because square root of 3 over square root of 3 is equivalent to 1. So up in the numerator here, square root of 3 times square root of 2 is the square root of 6. And then down in the denominator here, square root of 3 times another square root of 3, or square root of 3 squared, is just a 3. That is the final answer. And I know it really bothers you that this 6 and 3 are being divided, but what I would remind you of is that this isn't even a 6, it's square root of 6. Something really funky. It's like 2 point, I don't even know what it is. So when a kid says, oh, Abruzzo, you didn't simplify the 6 and 3, my answer to them is, I don't see a 6. Oh, sassy, right? So here's square root of 6 over square root of 11 for this next question. It doesn't simplify, which is kind of bad news because that means I have to rationalize. So to get rid of the square root in the denominator, I would multiply both numerator and denominator by that square root of 11. And that gives me a square root of 66 in the numerator. And then a square root of 11 times square root of 11 is just going to be an 11 in the denominator. So once again, 66 and 11 don't cancel or reduce because there is no 66 in that problem anymore. I know, get really jerky when I answer that question. All right, so here, we're going to have an equation. And the idea is if there's only one x showing up in the equation, square rooting is the right method. So your first step is to isolate the thing that is being squared. So whatever that is, isolate it. And then step 2 is to square root. And I'm going to write a big note to myself. It says right here, 2 answers. What they're referring to is we're going to have both positive and negative versions of the answer. It says the word usually because there's one exception. If it is 0, you can't have a positive and negative 0. So that's the case where you don't have to worry about plus or minus. So here, good news, the thing that's being squared is already isolated. So let's square root both sides of the equation. Square rooting an x squared is just x. And then here I just apply the square root, so my positive and my negative solution signs show up. And then square root of 16 is 4. You could separate your answers, x equals 4 and x equals negative 4. The plus or minus is just a shorthand way for us to write that. Now this next question, the x squared is what the x is being squared. That's the thing that I have to isolate. It's not isolated yet. We actually have to divide by 2 first. So x squared equals 25. Now I could square root both sides. I get x equals both positive and negative 5. Again, you can separate them if you like. So this time, we have to do a couple of steps to isolate that x. We're going to start by subtracting the 1. Sometimes I get kids who say they're going to divide by 2 first. That's cool, but then you're going to have fractions. So I don't know what that was. All right, equals 7. And then divide by 2, divide by 2. Now, I know that's a fraction. I know it's a decimal. Technically, they're both okay, but not when you're trying to simplify radicals. You want to leave it as a fraction. Because when you square root, I'd much rather square root this fraction to leave it in proper form. Bit of bad news, though, guys. That 2 is not going to reduce, so we're going to have to rationalize. We end up with x equals, go ahead and throw it on a plus or minus. Up top in this numerator, I have square root of 7 times square root of 2, so that's square root of 14. And then down in the denominator, square root of 2 times square root of 2 is a 2. 14 over 2 does not reduce because it's not 14, it's a square root of 14. All right, so here, the thing that's being squared is this x. We're going to start by adding the 5 over. So right now, it's still being divided by 3. We're going to have to get rid of that by multiplying by 3. Both sides, of course, on the equation. These 3's cancel. You get x squared equals 36, and that's a lovely answer, because when I square root both sides, I get 2 answers, of course, both positive and negative 6. My pen will cooperate. You know, when your tablet stops working, I think that's like a sign. Stop working, right? Almost there, Abruzzo, keep trucking. Now here, a little different because the thing that's being squared is actually the entire quantity x plus 5. So we're going to do this a little out of order. We're going to have to square kind of in the middle of the problem. But I still need to isolate that thing. So instead of having a 1/3, I want to get rid of that 1/3. I would multiply by a 3. right now on both sides of the equation. So 1/3 and 3 cancel. And I still have x plus 5 quantity squared equals 21. And do not, under any circumstances, distribute this squared, because that's not how that works. X plus 5 quantity squared is a foiling x plus 5 times x plus 5. So unless you really love quadratic factoring, don't do that. I would just square root both sides right here. So square rooting this is easy. That's just x plus 5. But because I just applied the square root, the plus or minus sign will show up now. And then I want to think about square rooting the 21. I want to see if it breaks down at all or partially, and turns out, no, it doesn't. So I'm just going to keep it as the square root of 21, which is a funky little irrational number. And then the last thing I'm going to do is I'm going to subtract the 5. I'm going to do it from both sides, though. And this is where sometimes you can get confused on notation. I like to write my answer as these are not combinable in any way, so I like to write the -5 first, and then I'm going to add and subtract in two different answers, square root of 21. Sometimes you'll see it as plus and minus square root of 21, and then a -5 off to the side. They mean the exact same thing. So I don't care which order you write it in, but you'll see me write it in this order every time. I just think it's easier to read if you put the plus or minus term on the back end. So the idea is one of your solutions is -5 plus square root of 21, and the other solution is -5 minus square root of 21. They're equally disgusting, but I don't really care what notation you write them in. So here on this question, the thing that's being squared is this. I want to isolate it. A very common mistake is someone thinks they're going to distribute the 5 into this. You can't, because it's not x minus 1, it's x minus 1 squared. So unless you FOIL it all the way out, you can't distribute that 5. So let's instead get rid of the 5 by dividing. So now I have x minus 1 quantity squared equals 10. Now I should square root both sides. Because this is the moment I applied the square root, this is also the... Oh, apparently that's what that means. Power source. Okay. Get rid of that signal. Apparently my battery's about to die. So let's hurry up and solve this. So we have plus or minus square root of 10. That does not reduce, so x equals 1 plus and minus square root of 10. And then this is one of my favorite problems. Multiply by 2. Boom. X plus 8, quantity squared equals 28. Hey, if I get cut off on this lesson, you just understand that I really enjoyed it, and see you next time. All right. X plus 8. This is where the plus or minus has to show up, though, huh? And this breaks into 4 times 7. So that would be 2 square roots of 7. And then I prefer the answer when you put the subtract 8 in front of the plus or minus. So my solutions are -8, and then both adding and subtracting 2 square roots of 7. I think this is just more practice. So depending on how your class does, we might skip over this entirely, or I might assign it to you. This Cutman question is kind of fun. It's that dropping a problem from somewhere and having it fall to the ground kind of a question. The idea is last time we had this question, we made you solve it by factoring, but this time they're going to have you solve it by square rooting, which makes more sense, right? So if we're going to drop to the ground, your final height is 0, and they're going to keep changing your position at the beginning. So like 0 equals -16 t squared plus, this time it's 100. So if I wanted to solve this through square rooting, I would, move some terms around. So I could subtract 100 over. And then I would divide by -16. I don't really have a calculator in front of me. But whatever this is, 100 divided by 16. And then your final answer is whatever the square root of 100 divided by 16 is. 5 over 4, so 6 point something. And instead of saying plus and minus, it wouldn't make sense to say -6 point whatever seconds. So 6 point whatever seconds is my answer. And then when you change your starting position, you're going to obviously have to increase your time. So when you solve it, you're going to see a number higher than that. All right. Oh, I don't know if I did that right. That wasn't 6. Was it? 10 divided by 4. Abruzzo. Your mental math better. 10 divided by 4 is 2 point something. Look at me trying to be fancy. All right. So bad news is my battery's about to go. Double bad news is I didn't get to do this problem where the Cutman drops out of the window. It's like my favorite problem too. It's a cool question. The only difference is instead of hitting the ground, your stunt man's going to hit the pillow, which is 9 feet off the ground, because you don't want him to die. So instead of the final H as being 0, let's see if I can squeak this problem in. The final height's going to be 9, because it says it's 9 feet high for the pillow. And then guess what? Same math. The position, and they use H sub naught a lot. That just stands for initial height. You'll see sub naught on all sorts of variables, initial time, initial height, initial temperature in chemistry. So for us, if the window's 100 feet up in the air, so whatever that ends up being, you're going to subtract 100, divide by -16. It's real life, so the decimal is appropriate, a decimal answer. And we're going to talk about the fact that plus and minus won't make sense here. Okay. Hey, we got most of the lesson in before the battery died. See you next time.